How are you guys? Seems like Dambo are kumirira and no one is joined. So what I was suggesting, I can just record a lesson. When we are free, you can view. Because I wanted to introduce the hypothesis testing. So today we want to look at hypothesis testing. We want to look at what we call hypothesis testing. Want to look at hypothesis testing. And let me just stay in. Maybe pana anozongoda join. No one. I was waiting bana 20 to 8. It's now 11 past. Apana ta join. Maybe network. Enyu yakadhakwa. So today I want to look at what we call hypothesis testing. And what do we say when we are looking at hypothesis testing? We are looking at statements. We want to test whether a given statement is true or false. So if you are given a certain statement and if we can check it if it is true or false, that statement we can reject it or we can accept it. So those statements, there are two types of statement. The first statement, I think we've looked at some of the statement when we did chi-squared test. We said there are statements which are called null hypothesis. And this null hypothesis is represented by H naught. So you can write somewhere for progress sake, you can write null hypothesis. This is the actual statement that we want to test, the actual claim that someone is claimed. My salary is 300 US. That's my null hypothesis. Data claim my salary is 300 US. That's my null hypothesis. It's the statement which can be rejected or can be accepted. That's the initial statement that anyone can claim. Even you can claim. You can claim on something else. That's the null hypothesis, H naught. Then the second statement is the alternative hypothesis, which is represented by H1. The alternative hypothesis, we are saying this is now the statement which opposes the null hypothesis. Like I said, my salary is 300 US. That's my null hypothesis. So one can reject it in so many different ways. So let's say my H naught, I'm saying my salary is 300. That's my mean salary. When we are doing hypothesis testing, we'll be looking at the mean yekunoma ya ndosana ndabvunza nchiti noma makaibata here. So I can say my the mean salary is 300 US. That can be my H naught. So for the alternative hypothesis, one can reject in 3 different ways. for H1. When I say my mean salary is 300, one can say no, your salary is not 300 but it's less than 300. So one can reject this. One can also say no, your mean salary is not 300 but it's what? It's greater than. Mu is greater than 300. Then one can say your mean salary is not 300. It's not equal to 300. And say mu is not equal to 300. So when I impose a statement that salary yangu is 300, we can reject that statement yekuti is 300 in 3 different ways. By saying mean mu is less than 300, one can say greater than 300, the other one can say not equal to 300. Right? So ndo zvinobva zvatipa yatinoti types of test. So meaning to say tine different types of test. So for the first two, ndechikumbira kuti muite muchinyora, the first two ine less than ine greater than, matest iwo anonzi one-tailed test. One-tailed test. The tests are called one-tailed test. These two tests, ane less than ane greater than sign, they are called one-tailed test. One-tailed test. One-tailed tests. And what are one-tailed tests? You can write one-tailed tests are a test where we are testing for either an increase or a decrease. Those are one-tailed tests. We are testing whether is the statement, are we testing for an increase or a decrease? Like in this case, like for the first scenario, we are testing. Tikada kudraw the curve redu normal. This is our curve for normal. This is less than sign. Apa ndopatoisa less than sign. Ndopanenge paine critical value edu. Critical value edu iri pa negative. So in this case, we are testing if there is a change in the negative direction. So my critical value here is negative. Also, kana ndiri kutesta pa this one for the second one, I'm saying ndiri kutesta for the upper-tailed test. So critical value yangu inenge ya positive. Here I've got a positive critical value. Here I've got a positive.
The sun was just starting to rise over the airport. It was quiet, peaceful, and cold. Inside the terminal, Ibrahim Traore waited calmly near gate 37. He didn't wear a suit. He didn't have bodyguards. He didn't carry anything flashy. To most people, he looked like just another African.
Right, fine. So here in this case, this is one-tailed test. These are directional tests. Yeah, the definition for one-tailed test, these are directional tests which test for either a decrease or an increase. Like this type of test, we are testing for a decrease. We might see keywords like less than, decrease, decline, below. Right, pese pamovhunzwa question ye hypothesis testing, ukasangana nemawords akaita sana less than, decline, decrease, depreciate, below, tikudhila this test. This test we are now testing for greater than. Tikazana nemawedzi akaita sana greater than, above, what else, above, increase, ese mawedziwo ane chekuita ne greater than sign. Those tests lie under one-tailed test. They are directional tests, right? Then we have this last one. This test is called the two-tailed test. This is the two-tailed test. And what is a two-tailed test? You can write it's a non-directional test which tests for a change. Haina direction. When one says salary yako is not 300, yes, it's not 300. My salary can be 250. It can be even 500. So hazina direction. If one specifically says it's not something, it's not hazina direction. We are saying it's a non-directional test. We are saying it's a two-tailed test. So the two-tailed test iri kubva papi yatoti two-tailed test. So tikada kudraw the graph redu renormal, ma critical values edu, there are two. Tine critical value iri ku negative ne critical value iri ku positive. So we have the two types of targeting two critical values, the positive and the negative. Because it's a non-directional test at no direction, right? So the first stage here hypothesis is to state your null and the alternative hypothesis. Then the second stage now is to find the critical value. How do you find the critical value? You have to find the critical value kana uchiziya type a test yako. Kana uine one-tailed test, my critical values, you simply say critical value edu, the critical value is just Z alpha. It's just Z alpha, where alpha is the level of significance. The one they say test at 5% level of significance, that is the alpha. Alpha is the level of significance. If they say test at 5% level, how do you find Z alpha? Tikaiti muine matables timboone kuti matables enyakamira sei, right? In this case, these are the Z alphas. Tikaenda kumatables edu, amugona ma-alpha edu aya. Tikazi test at 5%, this is 5%, 0.05. This is 10%, alpha edu 0.1. This is 2.5%. So the values of alpha, like if they say test at 10%, so the Z alpha will be 1.2815. That will be my critical value. Kana iri ku negative, ndenda kusa negative 1.28. Kana iri positive, ndenda kusa iri positive. So the critical value for both lower tailed test and upper tailed test is this Z alpha. But now in this case, where we have two-tailed test, I simply divide my alpha by 2. So my critical value will be Z alpha over 2. My critical value will be Z alpha over 2. Will be Z alpha over 2. Like for instance, when they say test at 5%, my alpha will be 5%. So my 5%, I'm going to divide my 5% into 2, and I'm going to get 2.5%. So I'm going to say my critical value is Z of 2.5%, and 2.5% is 0.025. Then the Z alpha, it will be 1.96. So in this case, my critical value will be minus 1.96 and positive 1.96. That will be the critical value for two-tailed test. So that's the second stage for testing the hypothesis. Then the next stage, you have to calculate the test statistic, the one which we usually compare or see whether that value is lying within the acceptance region or the rejection region. So we have what you call the test statistic. The test statistic. Ndofunga test statistic taimboiweka. Test. Our test statistic. And what is our test statistic? So it will be x bar, that is the sample mean, minus mu over sigma, which is the standard deviation, times root n. That is our test statistic. All the values you'll be given, the values. My values data couple. So we are going to look for an example. Teacher example. Don't expand yan. Mu ndian, sigma ndian, root n ndian. Sigma wacho na x bar tokunozoweka. Like takambotarisa ka. Handitakuziva kuweka x bar of ungrouped data. Sigma yan grouped data takuiziva. So I'm going to put data really ungrouped, especially ungrouped. Right, fine. Then the last October conclusion. Because we are saying this test statistic, going to get in this region. And region hombe, test statistic ekapindom. What do? We accept H naught. In this region, we accept H naught. We accept H naught. In this region, we reject H naught. So region hombe take accept, region dik true reject. So that will be the stages in hypothesis testing. So let's now look at our example question 4b. Right, let's look at our example number 4. Apa inyaya kuti handina calculator manje, saka tichaita sei manje. Let me try to explain. Iri kuti kudii, the statistics for clients visiting a psychologist assessment room within years indicate that those who had psychosocial challenges were 1.49%, 18%, 1.1%, 1.9%, 2.2%, 1.2% of the population. So these are our values. We are given these values: 1.49, 18%. But I think I think that 18% wasn't it an error? I see error. Angas for 1.8. I'm not mazo submit error assignment, but I think there was a typing error. Posikate some percentages eduka. Aruma 1 point. The maximum ingato ita 2.2. I don't know. And this would try to say, pause. I can put try kuzuma. My values they die. I'm from the pani 18 iri abnormal. There is a value iri abnormal. I guess for 1.8 era. Because we can we say 1.9% what data here 18 to 1.1, 1.9, 2.2 near 1.2. Amen. Toita sei. I think there was an error, but since it was ingori assignment, tangoita zviripo ipapo. So tichiona kudai also takapiwa mavalues aya. It's ungrouped data. Tine 1, 2, 3, 4, 5, 6. Totanga tatsvaga x bar mean. Tine yatinoti x bar mean a grouped data. So it's summation of x squared. Ndrukueda, it's summation of x. Ndichaeda. What's happening here? So it's the sum over n. I'm adding 1.49 plus tati tongotora 18 and tangotora 18 wacho plus 1.1 plus 1.9 plus 2.2 plus 1.2. I'm getting 25.89. Not divided by 1, 2, 3, 4, 5, 6. 6 divided by 6. No, 4.315. No meaning. Then chada sigma. The standard deviation. Yes, sample. How do I find the standard deviation for the sample? Sigma. Mama tables zenyu akamira sei. Takapuwa ere standard deviation. Yes, sample. Ish. This is the standard deviation of the sample. Or we can use this one. So in this case Trukuti it's 1 over what? Data redo zvingani? 1, 2, 3, 4, 5, 6. 6 ika. Sata kuti 1 over 6 minus 1 to wataona 1 over 5. To wata open a bracket up. Summation of x squared ushu. Zvirikuita Trukuita sei? Ndikuiti 1.49 ndom square. Ndoti plus 18 squared. Ndichieda 1.49 squared plus 18 squared plus 1.1 squared plus 1.9 squared plus 2.2 squared plus 1.2 squared. Ndinoona 337. Ndikuona 337.320.1. Then I say minus the summation of x. Summation of x tatoita kudare. No sum of x ish. Sum of x here. Papa ndaenda takuenda zvese andinozoiseva pai because iye yanga yato mean answer yacho. So let me try to add again. Ndisingaswei 1.49 plus 18 plus 1.1 plus 1.9 plus 2.2 plus 1.2 I get 25.89. I get 25.89. 25.89. Then I have to square this one. Then I divide by total. That is 6. Inenge variance. Tikaweka ichichi. Tikazochisa square root ndo standard deviation. So chese tikazochisa square root. After working, totachisa square root. Sarga titange tachiweka ndo ndatochisa square root. Zvobowa sengodzidzisa vanhu wasipo. Aiku muchangobata. Ikati ngatiweke ichi tochiweka sei? 1/5 ndi 0.2. 0.2 times I open bracket 337.3201 minus I open bracket 25.89 close bracket squared, then I divide it by 5. I'm not sure boss, pane zvandaita apa pasina kubuda zvakanaka. Ndoshandisa calculator pafone. Ndoita seya. Right. Ndoti mundipanjiro ichocho mochisa square root. Mene ntsvage calculator. Right. Pandaweka zviri mukati ndaona 45.1 45.1295 45.1295. So ndikachisa square root of 45.12095 ndinoona 6.72 ndikairound 6.72. So ndo 6. Sigma yedu 6.72. Now takuchitesta manje. Test at 5% level significance whether this supports the contents that the average visits are 1.5. Takutonorowa test yedu manje. Takutorowa test baba. Takutorowa test. Our H note takutangana H note. Tanziti test whether the visits are 1.5. Sando ye mi wedu ye. So takutesa 1.5. Ndiye mi wedu. So we are testing for what? Are we testing for less than? Are we testing for greater than? Or tatasa question yedu atina a keyword inoratidza kuti tikutesta for less than or even greater than sign. So this becomes our two-tailed test. Atina tangonzi tested 5% 0.05 level whether this supports the contents that the average visits are 1.5%. hatina kana even keyword rekuti less or. So we are saying our h1 we are now saying it's not equal to 1.5. It's not equal to 1.5. So this is our test. Though chata kunyora page 2, it's not equal to 1.5. So we are now ignoring the rest. If atichazvitarise takutodhila netest iyi, takutodhila netest iyi. So first stage h not wedu ndeuyu, h1 mowa mango munyora pazasi apa sezvizvi. Second stage tabva tatoona kuti this is a two-tailed test. Second stage takutotsvaga critical value. Iyi formula ye critical value ye two-tailed test ndakupai. Saka takuda kutongoona kuti critical value yedu apa ndiani. Imwe ichaita negative, imwe ichaita positive. Tanzi titest at alpha. Alpha wedu ndiani 5%. Saka 0.05 tikaidivide by 2 tinoona chi 0. Saka our z 0.05 divided by 2, what do we get? We get 0.025. Tato divide alpha wachona 2. Alpha anga 0.05. So divided by 2 tawataona z of this. So kuma tables z of 0.025 ndiani 0.025 is 1.96 up. Tukatutaisa alpha wedu 0.025 1.96. So here it's positive 1.96. Uku inenge yachi negative 1.96. Ndo critical value yedu. Tatoweka ma critical values to test. Then the next step tichingodzika tichongenda zvakadaro. Takuweka test statistic irapa test statistic nema kutoweka kana pazasi apa. In test statistic yedu iri kuti chi is equals to x bar. X bar taweka kapaya. X bar tamona richi 4.315. 4.315. Takunyora and this is blue. 4.315. 4.315. Then I say my mean mu. We are testing whether it is 1.5, so it's 1.5. Sigma over sigma. Over sigma buda richipa 6.72. 6.72. Then I say times root n times root 6. So todoti tiweke izvi tozozvi times ana root 6 tinoona chianze yedu ngatiweke 4.315 minus 1.5. Then I divide it by 6.72. Then my answer I multiplied by square root of what? My answer I multiplied by square root of 6. I get 2.51. I get 2.51. 2.51. Then ndakucheka kuti 2.51 ari kupi? 2.51 ari kumberi kwa 1.96. Sadoko ari uko. Aina rejection region. So you comment, comment up pamusoro kuti reject h not, comment up kuti reject, comment reject h not. Tatopedza test, takutorova conclusion. Sandoti munyore conclusion, since the test statistic, since 2.51 is greater than 1.96, we reject h naught and conclude that mu is not equal to 1.5. Antika reject h naught takutora statement isiri pa h naught is 1.5. So we are now saying since 2.1, the test statistics is is greater than 1.96, we reject h naught and conclude that mu is not equal to 1.5. So it doesn't support his claim. Tatopedza. Saka ndo hypothesis testing. Tatopedza this question in a 15 marks. So I will send you a similar question kana mapedza kuona video. So good night guys. Nazina kuita ndega lesson. Hapana kana mbojoina. Ndiite call off. Ndanchi record lesson. Toko nonga ndansuru record. Right, ndanchi record 36 minutes. Bo